Let's explore Mercury. It's the planet closest to our Sun, but don't assume that means constant heat. Surprisingly, Mercury experiences extreme temperature swings. At night, temperatures can plunge to a frigid negative 180 degrees Celsius. However, during the day, they can soar to a scorching 430 degrees Celsius. This dramatic imbalance is due to Mercury's lack of a substantial atmosphere. Instead, it has a very thin exosphere, which can't effectively trap and regulate heat. So, while weather isn't a concern on Mercury, other dangers certainly are. The main risks come from intense solar radiation and the absence of breathable air. Mercury receives nearly 7 times the solar radiation that Earth does. As the smallest planet in our solar system, Mercury's surface is rugged, covered with craters, cliffs, and uneven terrain. This makes landing a significant challenge. Plus, the lack of significant atmosphere also means low air resistance, which makes slowing a spacecraft difficult and increase the chance of crash. Forget about daytime exploration. The extreme heat is insurmountable. Even the most advanced NASA spacesuits can only withstand temperatures up to 121 degrees Celsius, far below Mercury's daytime temperatures of 430 degrees Celsius. Moreover, a day on Mercury lasts about half a year due to its slow rotation. Nighttime isn't much safer either. Temperatures of negative 180 degrees Celsius are well beyond the lower limit of NASA spacesuits, which is negative 157 degrees Celsius, so you'd freeze solid. The best hope for a landing would be in the Terminator zone, the region between day and night, where temperatures are milder. Even then, it's risky due to potentially rapid temperature changes. Now let's talk about Venus. Venus, the planet closest to Earth, sitting just 40 million kilometers away, making it a relatively short journey. Moving on to Venus. Roughly the same size and possessing similar gravity to Earth, it wouldn't initially seem so bad. However, those picturesque yellow clouds that greet you upon approach hide a deadly secret. They're composed of sulfuric acid. This highly corrosive substance would instantly devastate your lungs. Assuming you have a spacesuit sophisticated enough to filter the acid, as you descend further, visibility would plummet. The atmosphere becomes incredibly dense, primarily carbon dioxide, severely limiting what you can see. Add to that an unbearable heat of 450 degrees Celsius, and that's not all. The thick atmosphere blocks about 90% of sunlight, resulting in a dim surface. Simple movements become a monumental effort. Despite gravity being comparable to Earth's, the sheer density of the air makes you feel like you're wading through a thick liquid. A robust, pressurized suit might grant you a few seconds, but before long, the immense pressure, around 92 times Earth's sea level, would crush it. And even if the pressure didn't kill you, the sulfuric acid that would inevitably leak into the compromised suit would finish the job. Next up, Mars. Mars, the second closest planet to Earth and arguably the most habitable of the bunch. Daytime temperatures are significantly less extreme than on Mercury and Venus, peaking at a relatively pleasant 20 degrees Celsius. However, the real difficulty arises at night or in certain areas where temperatures can plummet to a frigid negative 133 degrees Celsius. A challenge on Mars, similar to Mercury, is its incredibly thin atmosphere. Largely composed of carbon dioxide, Mars's atmosphere, primarily carbon dioxide with only trace amounts of oxygen, presents another challenge. This limits breathable air, and the thin atmosphere leads to low pressure and significantly increases radiation exposure, both incredibly dangerous. The average natural radiation level is between 24 and 30 rads, roughly 40 to 50 times higher than Earth. Furthermore, Mars is prone to frequent and intensely powerful dust storms, with winds reaching up to 100 kilometers per hour. These storms pose significant challenges, so any successful habitation would require a sustainable, airtight, and well-insulated life support system. Now let's consider Jupiter. Jupiter, the largest of the 8 planets, is also one of the most difficult to land on. This is primarily due to the planet's extreme radiation levels. Even at 300,000 kilometers away, the radiation would begin to penetrate your suit, rendering it useless. But, for the sake of argument, let's suppose you possess a theoretical suit capable of completely blocking radiation. Jupiter's gravity is roughly 2.4 times stronger than Earth's, resulting in an incredibly rapid descent. As you enter the upper atmosphere, you would encounter white clouds composed of frozen ammonia crystals, with temperatures hovering around negative 150 degrees Celsius. The winds here are far from gentle, reaching incredible speeds up to 482 kilometers per hour. If you managed to descend approximately 150 kilometers through these top layers, you'd reach the deepest point ever explored. This is the farthest that NASA's Galileo probe reached back in 1995. Beyond this point, it becomes much darker, and both the temperature and pressure increase rapidly. Just for a point of reference, the pressure near Jupiter's core is estimated to be roughly 100 million times Earth's atmospheric pressure. After hours of freefall, you might reach. Descending further into Jupiter's depths, you'd encounter a supercritical fluidous strange state of matter that's neither truly liquid nor gas. You'd be almost swimming within this odd substance. Continuing toward the center, you'd find metallic hydrogen, an incredibly dense liquid that would likely trap you. If you somehow made it through that, you'd reach Jupiter's core, though whether it's solid or not is currently unknown. The temperatures there would reach approximately 24,000 degrees Celsius, roughly 4.5 times hotter than the Sun's surface. Now, let's consider Saturn. Saturn, the second largest planet in our solar system, boasts an atmosphere primarily composed of hydrogen and helium. The initial challenge would be navigating the planet's 146 orbiting moons without colliding with one. Once you manage to avoid that, you'd face its iconic rings, composed of debris from old moons, ice pellets, comets, and asteroids. Let's assume you're either an incredibly skilled pilot or your spaceship is utterly indestructible, so you don't meet your demise by crashing into space junk. As you approach Saturn's equator, you'd witness a spectacular display of red and purple auroras caused by highly energetic hydrogen in the atmosphere. However, this beauty comes at a price. Hurricane, force winds, reaching speeds of about 1,800 kilometers per hour, would make it virtually impossible to maintain a steady position. Attempting entry via the North Pole wouldn't be an improvement. Up there, you'd face a massive storm, large enough to fit 2 Earths inside. This region also features ammonia clouds similar to Jupiter's, and temperatures that can plunge to a bone-chilling negative 250 degrees Celsius. As you descended deeper through the cloud layers, the temperatures would begin to rise again, eventually reaching 0 degrees Celsius at this point. While the extreme cold becomes less of a concern, pressure quickly emerges as your greatest adversary. It escalates to levels similar to the deepest regions of Earth's oceans. Continuing to descend, the surrounding gases would transition into a liquid state. If you somehow managed to survive long enough to reach the center of Saturn, you'd encounter its molten rocky core, approximately 10 times the size of Earth. Temperatures there reach a blistering 11,700 degrees Celsius, more than twice as hot as the Sun's surface, with pressures roughly 1,000 times greater than Earth's. Now, let's journey to Uranus. Uranus marks a point where planets begin to get truly distant from Earth, making travel exceptionally long. It's one of the 2 ice giants and the only planet in our solar system that rotates on its side. Furthermore, Uranus has a faster rotation than Earth, with a day lasting only 17 Earth hours. By the way, being an ice giant doesn't mean it's a solid ball of ice. Instead, it indicates a composition primarily of elements heavier than hydrogen and helium. Like Saturn, you'd need to steer clear of its ring. Once past them, you'd find yourself enveloped in toxic gas, and the temperature would plummet rapidly to below negative 200 degrees Celsius, making it the coldest planet in the solar system. If the freezing cold and poisonous atmosphere didn't get you, you'd descend through the first layer of the atmosphere, where conditions only worsen. The air becomes dense, and you'd be bombarded with ice pellets. Eventually, you'd reach a truly extraordinary phenomenon, a rain of diamonds, driven by winds reaching up to 900 km/h. But again, there's a catch. The pressure here is about 100 times greater than Earth's, which would ultimately crush you. Next up is Neptune. Neptune is the second ice giant after Uranus, and finally we arrive at Neptune. Neptune shares a remarkably similar composition to Uranus. As the most distant planet from the Sun, orbiting approximately 30 times further than Earth, Neptune is shrouded in perpetual darkness. Like its icy twin, Neptune's outer layers are frigid, but the inner layers boast incredible heat due to the immense pressure and heat emanating from its core. In fact, its core temperature reaches around 7,000 degrees Celsius, exceeding the Sun's surface temperature. Just like Uranus, Neptune experiences diamond rain, caused by high pressure breaking down methane molecules and forming solid diamonds. Neptune also features some of the most powerful winds in our solar system, reaching supersonic speeds. In many respects, Neptune is essentially a twin of Uranus, so there's not much more to add. If you enjoyed this video, please subscribe for similar content or join my Discord server to suggest future topics.